Day 22. Okay, we're going to use Pythagorean's theorem to do this. And in Pythagorean's theorem, a squared plus b squared is equal to c squared. These are always the legs of a triangle, of a right triangle, which are touching the 90 degrees. And this is always the hypotenuse. I don't want to misspell that. Hypotenuse of the triangle, and that's always the side opposite the right angle. So this is the hypotenuse, and these are the legs. Okay, so 3 squared plus 4 squared is equal to c squared. 9 plus 16 is equal to c squared. 25 is equal to c squared. Now normally we would get plus and minus 5. But a physical dimension cannot be negative, and so we have to throw out the negative solution, and our answer is only 5. Now mathematically, if this did not represent a triangle, we would have the plus and minus 5, just to be clear. So C is 5. Okay, so these are your legs. So 5 squared plus 12 squared is equal to c squared. This is 144. This is 169. So c is equal to the square root. And again, we would normally get plus and minus, but we cannot have a negative physical dimension. So this is going to be the square root of 13 and only the positive. The square root of 169, which is 13. Okay, in this problem, the b and the 4 are the legs. So b squared plus 4 squared is equal to the square of the hypotenuse. So b squared plus 16 is equal to 144. So b squared is equal to 144 minus 16, which is 128. So b is equal to the square root. And again, I'm a broken record. Normally you'd have plus and minus, but this is a physical dimension, so we only have the positive. And I'm going to write this as the square root of 64 times 2. When we square root the 64, we get 8. So this is going to be equal to 8 times the square root of 2. Okay, so the b and the 6 are the legs. So b squared plus 6 squared is equal to the square of the hypotenuse. So we have b squared plus 36 is equal to 81. So b squared is equal to 81 minus 36, that's 75/45. So b is normally plus and minus, but we can't have a negative physical dimension. So this is the square root of 45, which is the square root of 9 times 5. And when we take out a 9, that becomes a 3. So this is going to be 3 times the square root of 5. Notice I'm not putting any units on here because the original problem didn't have units. So this is a unitless answer. Okay, our legs are the 5 and the a. So a squared plus 5 squared is equal to, there's our hypotenuse. So a squared plus 25 is equal to 81. So a squared is equal to 81 minus 25, which is 76, 66, 56. So a is equal to the square root of 56. Well, let's see. 56 is 2 times 28, 2 times 14. Can hardly write. So this is equal to the square root of 2 squared times 14. And when we take out the 2 squared, we get 2. So this is equal to 2 root 14. Okay, our legs, this is out of focus, but our legs are a and 7. So a squared plus 7 squared is equal to the square of the hypotenuse. So a squared plus 49 is equal to 121. So a squared is equal to 121 minus this, so that's 72. So a is equal to the square root of 72. which I'll write as a square root of 36 times 2, because 36 is a perfect square. And when we take that out, we square root it, and we get 6, and we're left with the square root of 2. Okay, we have two ordered pairs. I'm only going to draw the first quadrant so we can kind of think about this. But 1, 1 is a point about there. 6, 13 is a point 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's a point about right there. The distance between these 2 points is that right there. So we can create a right triangle. This y value is the difference in the y's. In other words, it's y2 minus y1. This is the difference in the x's. In other words, it's this value here of the x's minus x1. Okay, so you don't have to draw this out as long as you understand that this is what you're doing. So the distance between the x values is going to be our x2 and our x1. So this is going to be 1 minus 6. The distance between the y values is going to be 1 minus 13. Okay, so this distance is negative 12. This distance is negative 5. Now, remember, those are the legs because this is a right triangle. So we'll call this C. C squared is equal to negative 5 squared plus negative 12 squared. And notice that it didn't actually matter which way we subtracted, because if we had subtracted backward, this would have been a positive 5. But either way, once you square it, you're still going to get 25. So it makes no difference which way you subtract because you're going to square it. 12 squared is 144. So when we add these up, we get 169. Okay, that's C squared. So C is equal to the square root of that. And again, it cannot be negative because it's a physical distance. So the square root of 169 is 13. So the distance between these 2 points are 13. Now, the formula is C is equal to the square root of the difference of the x's squared plus the difference of the y's squared. And remember, it doesn't matter if we put the x1 first or the x2 first, and the same for this. The direction that you subtract makes no difference. So that's the formula, and we'll use that on the next problem. Okay, so here we have 2 points. Remember, we figured out the formula in the last problem, and I'll just paste it here so we can just use that. All right, so our C is equal to the square root of the difference of the x's. So 8 minus 2, you could have just put 6 squared, plus 13 minus 5. And again, if I had done 5 minus 13 or 13 minus 5, it makes no difference because once I square it, it's going to get rid of the negative. So this will be 6 squared plus 8 squared, or 36 plus 64, or 100. The square root of 100 is 10. Okay, again, remember the formula is like this. So when I get C, it's equal to the square root of the difference of the x's. 3 minus a negative 6, or 3 plus 6, is going to be 9. And then 5 minus a negative 4, 5 minus a negative 4 is a 5 plus a 4, which is a 9. And again, look, I subtracted backward here and forwards here. It makes no difference the direction I subtracted, because once you square it, you'll get rid of the negative. So this is equal to the square root of 81 plus 81, which is a square root of 162, which is equal to the square root of 2 times 81. And when we take out the 81 out of the square root, we'll get 9. So this is going to be equal to 9 root 2. Okay, so those are our 2 points. We'll use the formula. There's the formula. And so C is going to be equal to the square root of the difference of the x's. So it makes no difference which way you subtract. -1 minus a -7, which is going to be the square root of -1 plus 7, which is 6. Okay? And then for the y's, we have 7 minus 5. I could have done 5 minus 7. It's okay either way, which is a 2. And this is going to turn into the square root of 36 plus 4, which is a square root of 40. So I'll write this as the square root of 4 times 10. And I can take out the 4, and that becomes a 2. Okay, so the formula, let's just paste it here, is like that. So I have C is equal to the square root of the difference of the x's. So something like -4 minus a -8 squared, which is -4 plus 8, which is 4 squared. Okay. For the y's, I have 2 minus 1 squared, which is 1 squared. So this is going to be equal to 16 plus 1, which is equal to the square root of 17. And that cannot be simplified, so that's just your answer. And you're done. Okay, so we have a weird ordered pair here, but that's okay. So let's just look at the formula. Let me scrunch this down and fit it right there. Okay, now, so this value here is our x1. This value here is our y1. This value here is our x2. And this value here is our y2, according to that formula. Okay, so now C is equal to the square root of the difference of those items squared. So we have x minus y minus this. When we subtract that, I have to distribute the negative. So I'll have a negative x minus y, because I'm subtracting both of the coordinates, not just the first coordinate, squared. Plus the difference of our y's, y2 minus y1. So I have y2 is x minus y squared. Okay, so this is going to be the square root of -2y squared. And here I have a binomial squared. A binomial is the first item squared, twice the product of the two items, and then the last item squared. -2y squared is a positive 4y squared. Then I have all this stuff. These are like terms, and that adds up to 5. So I have this is equal to the square root of 5y squared, and you can put this in any order you want. I'll put it in descending order of y's. So I have 5y squared minus 2xy plus x squared, and it could have been in a different order, but that's the final answer. Page 543. Okay, the question's asking, these don't appear to be like terms because the indexes are not the same. But we can simplify. In other words, a square root of 64 is 8. The cube root of 125 is 5. And the fourth root of 16 is 2. So we can quite easily add these up and get 15. Okay, square root of 36 is 6. The square root of 100 is 10. 6 minus 10 is -4. Done. Okay, at first glance, these don't look like terms, but this can be rewritten as 2 times the square root of 16 times 3. And when we take the 16 out, it becomes a 4. So we have -2 times 4 times the square root of 3, or -8 root 3. For the 25, we can write this as 25 times 3. And when you take out the 25, it becomes a 5. So we have 3 times 5 times the square root of 3, which is 15 times the square root of 3. Now they're like terms. If you had -x plus 5, if you had -8x plus 15x, you would end up with 7x. The term, as long as it's like, remains the same here. So we do the same thing. -8 root 3 plus 15 root 3 is 7 root 3. And you're done. Okay, I'm going to simplify these. This is the cube root of 8 times 2. We take out the 8 and it becomes a 2. 54 is 27 times 2. We cube root the 27 when we take it out and it becomes a 3. So we have 4 times 3, which is 12. So now we have a +2 plus 12, which is a +14 times the cube root of 2. Now be very careful to remember to write your index. It's a common mistake to forget to write that at some point. Okay, so this is the fourth root of 16 times 2. When we take out the 16, we fourth root it and we get 2. And this is already simplified. So now we have like terms because they're both fourth roots of 2. So 2 plus 3 is 5 times the fourth root of 2. Okay, here I'll write 6 times the square root of 9 times 2. So that when I take out the 9, it becomes a 3. And I have 6 times 3 times 2, which is 18 root 2. Okay, the 32 is 16 times 2. And when I take out the 16, it becomes a 4. And I have the root 2. And finally, I'll write this as 2 times the square root of 25 times 2. That's 50. And I take out the 25 by square rooting it. The 2's already out there. The 25 becomes a 5, and I'm left with the square root of 2. And 2 times 5 is 10. And these are all root 2, so they're like terms. So I have 18 minus 4, which is 14, plus 10, which is 24. Okay, root 6 cannot be simplified. Root 10 cannot be simplified. These are not like terms, so this cannot be simplified. And that would be your answer. Okay, this first one cannot be simplified. This second one I can write as a 4 times a 5. And when I take out the 4, it becomes a 2. So I have a 3 out there. The 2 comes out, and I'm left with root 5. So this is 6 root 5. Okay, and this, I have the 4 sitting out here. I'll write the 45 as 9 times 5. 9 can come out and it square roots and becomes a 3. The 4 is out there already. The 3 came out. I'm left with root 5. So this is a 12. Root 5. 4 times 3 is 12. And now these are all like terms. They're all root 5. So I have a 2 plus 6 is 8, plus 12 is 20. And I have my root 5. Okay, this first one cannot be simplified. So I'll just write it down again. This next one is 4 times 2x. And I take out the 4 and it becomes a 2. Okay, this last one I'll write as a 36 times 2x. And I'll take out the 36 by square rooting it and it becomes a 6. And I'm left with the root 2x. Now I have like terms. They're all root 2x. So I have 8 minus 2 is 6. 6 plus 6 is 12. And that's the answer. Okay, so I'll rewrite this first one as 36 times 2 m to the 4th times m. I have my 3 sitting out here. I take out my 36 and it becomes a 6. I take out my m to the 4th and it becomes m to the 4 divided by 2, which is 2. And I'm left with root 2m. So 3 times 6 is 18. Okay, so that's the first term. Minus. I'm going to have my 5 out here. I'll rewrite this as 16 times 2 m squared. So I have my 5 sitting out there. I take out my 16 and it becomes a 4. I take out my m squared and it becomes an m. And I'm left with root 2. And there's no m in there. So this becomes 5 times 4 is negative 20 m root 2. Now if you look at the portion after the variable, after the coefficient, this is an m squared root 2m. This is an m root 2. These are not like terms and they cannot be simplified. So that is your final answer. Okay, so I'm going to rewrite the 72 as 36 times 2. I'll rewrite the 32 as 16 times 2. Okay, now in this problem I have my 3 sitting there. I take the 36 out and it becomes a 6. The square root of 36 is 6. I take this out and it becomes an m. And I'm left with root 2. 3 times 6 is 18. M root 2. Now on this one I have my 5 sitting there. I take out the 16, it becomes a 4. I take out my m squared, it becomes an m. And I have root 2. So this is minus 20 m root 2. Now if you look at the portion after the coefficient, this is m root 2 and this is m root 2. They're identical, so these are like terms. So I take my 18 minus 20 and I get negative 2, and then the variable portion, everything after it, remains the same. M root 2. And I'm done. Okay, so I'm going to rewrite this as negative cube root of 27 times 2, because 27 is a perfect cube and it comes out as a 3. Okay, plus I have my 2 sitting here, and I'll rewrite the 16 as 8 times 2, because 8 is a perfect cube and it comes out. Now my 2 is just sitting there, but when I cube root the 8, it becomes a 2, and I'm left with the cube root of 2. This 2 times 2 is 4. So I have negative 3 times the cube root of 2 plus 4 times the cube root of 2. That's a positive 1 times the cube root of 2. But just like you wouldn't write, like if you had negative 3x plus 4x, you would write x. You never write the 1 times anything. We do the same thing here. We do not write the 1. We just write the cube root of 2. And it's understood that that's 1 times the cube root of 2. Okay, 27 is a perfect cube. So I have my 2 sitting out there. Let me write this in a different color. I have my 2 sitting out there. I take out the 27 and it becomes a 3. And I'm left with the cube root of x. So this is 6 times the cube root of x minus. I take out the 8 by cube rooting it. Now the 2 is sitting out there. The 8, when I bring it out as a cube root, it becomes a 2. And I have the cube root of x. So this becomes minus 4 times the cube root of x. And again, these are like terms. 6 minus 4 is 2. And I have the cube root of x. Okay, the first one nothing can come out. So this I just write down again. It cannot be simplified. But this one, I can take an 8 out by cube rooting it, and I get a 2. And I'm left with the cube root of the x squared y. Well, these are like terms. Remember, this is like a 1. 1 minus 2 is negative 1. But I never, like if I had x minus 2x, I would write negative x, not negative 1x. The same thing applies here. This is just a negative cube root of x squared y. Don't write the 1. Okay, this first one is completely simplified, so I'm just going to write it down again. This second one I'll rewrite as 8x cubed times x y squared. Now, the 2 is just sitting there. When I take out the 8, it becomes a 2 because I'm cube rooting it. When I take out x cubed, it becomes an x. And so this is going to be a negative 4x, and I'm left with the stuff that couldn't come out. And I still have this stuff, which is 3x times the cube root of xy squared. So these, now I'm looking at everything after the coefficient. I have x cube root xy squared, x cube root xy squared. They're identical. So I go 3 minus 4 is negative 1. Now, again, I'm not going to write the negative 1. I just write negative x cube root xy squared. Now, just a little note here. Make sure your exponent is completely contained within the radical symbol. If you were sloppy and you wrote it like this, negative x, and then you wrote your cube root like this means something entirely different and would be marked wrong because this is an x cubed times the square root of xy squared. You have to write that 3 in the index, in the pocket of the radical there. Okay, so I'm going to rewrite my 32 is 16. And by the way, if you don't know this, 32 is 2 times 16, 2 times 8, 2 times 4, 2 times 2. So this is equal to 2 to the 5th power. But 5 is not divisible by 4, so I'll write this as 2 to the 4th times 2. So the 5 is sitting there. When I take this out, it becomes a 2, and I'm left with the 4th root of 2. So that's the first one. And then I'll do the similar thing to 162. This is 2 times 81. This is 9 times 9. This is 3 times 3. 3 times 3. So this is 2 times 3 to the 4th power. So I have my 3, and I have the 4th root of 2 times 3 to the 4th power. So I have my 3 sitting there. When I take this out, it becomes a single 3 times the 4th root of 2. So this is 5 times 2, which is 10, times the 4th root of 2, plus 3 times 3 is 9, times the 4th root of 2. And those are like terms, so I add them up. 10 plus 9 is 19, times the 4th root of 2. Okay, this is the 4th root, so I'm going to rewrite this as the 4th root of x to the 4 times x times y. And when I take this out, it becomes an x. So I have 3x times the 4th root of xy minus, and I'll just write this down, 2x times the 4th root of xy. So when I look at the variable part, this is x 4th root xy. This is x 4th root xy. So they are like terms, and I subtract. 3 minus 2 is 1. But again, you don't write the 1. You just write x times the 4th root of xy. Again, be careful to contain this 4 within the end of the radical so it doesn't become an x to the 4th times the square root of xy. Okay, this is 2 times the 4th root of 16a cubed times 2. That's 16. I should have just written the 16 times 2. But anyway, the 2 is sitting there. When you 4th root 16, you get another 2 on the outside. And then it's the 4th root of, well, 2a cubed, the stuff left behind. So this is going to be 4 times the 4th root of 2a cubed. Plus, this is already simplified. So these are like terms. 4 plus 5 is 9 times the 4th root of 2a cubed. Okay, here we have fractions. You need a common denominator. So I need a 6 on the denominator. This one on the right didn't change, but the one on the left you had to multiply by 2 to get to a 6. So I got to do the same thing up top. So this is going to be a 4 root 5. And now you can put it all over one denominator, and I have a 4 root 5 plus 1 root 5, which is 5 root 5 over 6. Okay, there's a ton of ways to go about doing this, but one way is to do the square root of 8 over the square root of 9, which is, this is like 4 times 2. So this is going to be 2 root 2 over 3 plus. Now the square root of 18 is the square root of 9 times 2. So this is going to be 3 root 2. When you take out the 9, it becomes a 3. And the square root of 36 is 6. And now you need a common denominator, which is going to be 6. This one on the right doesn't change. Oops, that's a 3 root 2. Okay? But this one on the left, you have to multiply by 2 to get there. So you got to do the same thing up there. So this will be a 4 root 2. And finally, these are now like terms. You can put them all over 6. And you have 4 root 2 plus 3 root 2 is 7 root 2 over 6. And you're done. Okay, we have a common denominator already because the square root of 9 is 3. So now I can just do this. I can say the square root of 32 is 16 times 2. By the way, this is all over 3. This is plus 2 root 2 minus root 2. When I take out the 16, it becomes a 4. These are all like terms in the numerator. 4 plus 2 is 6. 6 minus 1 is 5. So I have 5 root 2 over 3. There's a ton of ways to do this. I'm going to do it like this. I'll say 3 times the square root of 25 times 2 over the square root of 9. this becomes a 3. And up top we have a 5 root 2, because this comes out as a 5. And then these 3's cancel, so this term is simply a 5 root 2. Okay, now let's look at this one. This I'm going to cancel. This becomes a 1, and this becomes a 4. So I have a plus 8. Now the square root of 1 is 1. The square root of 4 is 2. So I have 8 times a half. This cancels and becomes a 4. So this becomes plus 4. And these are not like terms, so you cannot simplify further because they cannot be combined. Okay, so I'll take out this 25, and that's a 5. I'll take out the x to the 8, and that's an x to the 4, minus, I'll take out the 9, and that's a 3, and I'll take out the x to the 6, and that's an x to the 3. So the common denominator is not x to the 12th, it's x to the 4. Okay, this one on the left we don't have to do anything to because it's already there. But the one on the right we have to multiply by x to get to x to the 4. So this will be a 3x. And so now that we have a common denominator, we can write it all over that denominator. And we have a 5 minus 3x. Those are not like terms, so they cannot be simplified further. Okay, 51, the perimeter is the sum of all 4 sides. So we have 3 root 20 plus 2 root 45 plus root 75. Now I'm going to simplify these. These are 3 root 4 times 5. I take this out, it becomes a 2. I multiply by that 3, and I get 6 root 5. This is 2 times 9 times 5. I take this out, it becomes a 3. I multiply by the 2, and I get 6 root 5. This is 25 times 3. I take out the 25, and it becomes a 5 root 3. These are like terms, and they add up. 6 root 5 plus 6 root 5 is 12 root 5. Plus 5 root 3. I cannot combine those. Oops. And this is in inches because we had inches. So don't forget to put your unit on there. Okay, the perimeter of a rectangle is all 4 sides added up. Or you can take 2 times 2 of the sides added up. Okay, so root 48... let's see, is 16 times 3. And when you take out the 16, it becomes a 4. 192 is, well, let's see, 192, oops, what did I do? 192 is 2 times 96. This is 2 times 48. This is 2 times 24. This is 2 times 12, 2 times 6, 2 times 3. So this is going to be 2 to the 1, 2, 3, 4, 5, 6. So when I take out the 2 to the 6, I get 2 to the 3. Which is 8. I'm going to bring this up here. So this is 2 times 4 root 3 plus 8 root 3, which is 2 times 4 plus 8 is 12 root 3, which is 24 root 3. And don't forget, this is in meters. So this is a meter. Okay, so the perimeter is the sum of all 4 sides. I don't think you can necessarily assume that this is a perfect rectangle, although it probably is. But you can't just add up 2 sides and multiply by 2 just in case it's not a perfect rectangle. Okay. This is 4 times 3. So, oops, let's just do this in one step. I take out the 4, it becomes a 2. I multiply by the 3, and it becomes a 6. This 18 is 9 times 2. I take out the 9, a square root, it becomes a 3. I multiply by the 4, and I get 12. Okay, this is 36 times 3. I take out the 36 by square rooting it, it becomes a 6. And finally, this is 36 times 2. I take out the 36, it becomes a 6. I multiply it by the 2 that's out there, and that's a 12, and I'm left with root 2. Now I got to combine like terms. 6 root 3 and 6 root 3 add up to 12 root 3. And 12 root 2 plus 12 root 2 adds up to 24 root 2. I need a unit, so I'm going to put parentheses around that entire thing and call this inches because we're dealing in inches. And that's that.